I think, than the ionic compounds were. So, first off, you're going to hear two terms pretty frequently. You're going to hear the idea of covalent compounds or molecular compounds. Now, strictly speaking, okay, these are actually molecular compounds. But the way this works, okay, is that molecular compounds, okay, have covalent bonds. Okay, so technically, to be perfectly strict, the bonds are covalent, the compounds are molecular because they are made up of molecules. Okay, so definitional-wise, that's easy. Now, of course, I said all that, and you're looking at this big, giant yellow table here. You need to know these prefixes. Now, most of these are things that you've probably seen before, at least heard before, and are easy to remember. So you've got mono is 1, okay, di is 2, tri is 3. Those are all pretty simple. It gets a little bit harder after that. Tetra is 4, and you probably haven't heard that before, so that's one that you'll definitely sort of want to put a little check mark beside, like, okay, I need to remember that one. Penta and hexa, you've probably heard before. Pentagon, okay, the Defense Department buildings, 5-sided. Hexagons are 6-sided. Octagons are like stop signs, they're 8-sided, so you've probably heard of all those. The ones that usually cause a little bit of problem are tetra being 4, hepta being 7, nona being 9, and 10 being deca. And just think of decade, 10 years, that's what 10 is. So you do have to know all of these. And of course you can use the chart as we're learning them, but you eventually need to get them in your head. They're not really that hard though. I mean, you know, at this point in high school, I mean, you should know that tri means 3 and di means 2. I mean, that's not massively difficult. Okay, so big wall of notes, I know. Okay, so we're going to take all the notes on this one slide, and then we're going to go put all these things into practice. So the way this works is that you're going to have two elements. We're talking about binary molecular compounds, just like we started with binary ionic. And remember, binary means 2, okay, of whatever it is. So the way that it works is that the less electronegative element is given first. So for instance, this is an example of a molecular compound. We've drawn the structure a couple times, OF2. Fluorine is the most electronegative, so it goes at the end. The least electronegative, or the less electronegative element, has to go first. So in this case, that's oxygen. Okay? So that has to be the thing that goes first. You don't do anything to the first name. You leave it as it is. Okay? And you give it a prefix if it has more than one. Now, most of the time, in fact, a lot of the time, the first element is only going to have one thing. Remember, if it doesn't have a subscript, it only has one. If that's the case, it does not get a prefix. You don't put a mono in front of the first thing. Okay? You leave it as it is. So I would start this compound out, and the first thing that I would write would be that it's oxygen. Okay? That's the first part. Okay? The second element, we're going to write that. We're going to put a prefix in front of it. Okay? And we're going to change the ending to IDE. So there's kind of 3 steps there. You write the name of the element, you put a prefix in front of it, and you change the end to IDE. Now, we've already changed the ending of fluorine to IDE before, so we sort of know how that works. And the prefix for 2 is di. So that means difluoride. Okay? So if we're going to name this compound then and give it its full name, it's going to be oxygen difluoride. Okay? So, a little hard, okay? Hopefully not too terribly difficult, but, and I know that's a giant wall of text, and I think when we walk through these, you're going to see how incredibly easy these are, okay? So let's do a few. So we're going to name this, okay? We've got carbon. There's 1, but remember, we don't put a mono in front of it if it's the first thing, okay? Next thing is oxygen. Now, oxygen, I know, turns into oxide, okay? Change the ending to IDE, so that becomes oxide. And then we put a di in front of it, so carbon dioxide. And you guys kind of knew that anyway. That's what CO2 is, and CO2's name follows exactly along with chemistry naming convention, so it's carbon dioxide. Okay, next one, we've got sulfur. I've only got 1 of them, so I don't put a prefix. Okay, we don't put a mono in front of the first one. And then I've got fluorine again. Okay, we know that fluorine turns into fluoride. Okay, and then I need to put the prefix in front of it for 6, and the prefix for 6 is hexa. So it becomes sulfur hexafluoride, and we've already talked about that before. We did shapes. That's the stuff that gives you the real deep demonic voice. So sulfur hexafluoride. Hexa means 6. Okay? Now let's look at the last one because this is one of the first ones that we have where the first thing is not 1. So I've got sulfur again. But this time I don't just have 1, I've got 2. So I have to go back and put a prefix in front of it. You leave the prefix off if it's 1, as it was in these two cases. But if it's not 1, you've got to put the prefix. So disulfur. Okay, chlorine is going to change into chloride. Okay, again, that's a pretty common one. And then 8, whenever you see 8, think about a stop sign. A stop sign has 8 sides, and it is an octagon. Okay, so disulfur octachloride. And again, the names sound weird, but the process of doing that is really easy. You'll notice there was no crisscross here. There was no figure out what the charge is because these are covalent. They don't have any charges. Okay, so you just name how many of them there are, basically. And that's really about as easy as it is. If you've got the name and you have to find the formula, honestly, that's even easier. So the way that works is that you just write down the symbol for the element. So carbon, oxide is oxygen, and my prefix is, I don't have a prefix for carbon, there's nothing there, so that's 1. And my prefix for oxygen is mono, and so that's 1. And so CO is my name, that's it. For the next one, phosphorus pentafluoride, I've got phosphorus. Fluorine is F. My prefix is penta, and penta means 5, and so it's phosphorus pentafluoride. And you see how incredibly easy that is. That is not terribly complicated at all. Let me move a couple things over to make sure that I'm getting all this other good stuff on the screen here. So the last one that we want to try is dicarbon hexahydride. Sounds really nasty, but carbon is C, and di is 2. Okay, so I put a 2 in front of that. And then hydrogen is hydride. Remember, we talked about that in the last video, that if it's IDE and it's hydride is hydrogen. And then hexa means 6, just like it did in the last slide, so C2H6. Now, this compound, and indeed some of the others, this has another name. This is an organic compound. If we were going to name this according to organic rules, it would be ethane. But those rules are actually way more complicated than this. This is really simple. Count the number, okay, or the prefix tells you what the number is, and you just write the symbol. So real simple, guys. All right. Something a little bit more complicated, but not really a whole lot, are acids. So we're going to learn how to name acids real quick. How do you know if something is an acid? Almost everything that starts with an H is an acid. Now, there are a couple of exceptions. Water and hydrogen peroxide. Those two things are not acids. Actually, technically, they can be, depending on the situation. But everything else, if it starts with an H, it is probably an acid. And so we're going to use these acid naming rules for that. These are what we call binary acids. There's 2 things in them. Okay, hydrogen and chlorine, hydrogen and fluorine, hydrogen and bromine. They all get named the same, and it's real simple. For any acid, you're going to take the name of the anion. Okay, so we're going to have chlorine or chloride. Okay, so chlorine is the name of the anion. Fluorine down here. Okay. And then down here we've got bromine. So you name the anion. And then to make it an acid, if it's a binary acid, which all of these are, just hydrogen and then just one other element, we're going to put in front of it, we're going to put hydro. That sort of represents the hydrogen. Okay, so hydro in front of all of these. That's a prefix. And then we're going to change the ending, not to IDE this time. Okay. But we're going to change the ending to IC. Okay? So we change the ending and it becomes hydrochloric and hydrofluoric and hydrobromic, and then we add the word acid after it. That's really all there is to it if they're binary acids. Now these are most of the binary acids. There's another one that's pretty common, which would be HI. You'll notice that these are all halogens. Okay, and so that would be sorry for the bad writing there, guys. Hydroiodic acid, okay? Because I is iodine, I cut the end off, put IC at the end, and I put a hydro in front of it. It becomes hydroiodic acid, okay? So not difficult again there. I think you guys can handle that. Those are binary. Now, most acids, though, are not binary. They're what we call ternary acids. Now, remember when we talked about ternary ionic compounds? we said that it meant that they have a polyatomic. Okay? So almost all of our polyatomics, at least all the ones that we're going to worry about for acids, they all end in one of two things. They all end in either ATE or ITE. Okay? So you had sulfate, sulfite, you had chlorate, chlorite, hypochlorite, okay, perchlorate. They all end in ATE or ITE. So there are two ways then to name acids if they have a polyatomic. So the first way is if they end in ATE, you write the name of the polyatomic, just like we wrote the name of the anion before. So we're going to write the name of the anion. Name of this anion is nitrate. Okay? And so all we do here then is we go back and we cut the ending off, just like we did before, okay, for the other acids. And I'm going to change the ending to IC, and I'm going to write the word acid. Okay? So HNO3 is nitric acid. For this one, SO4 is, let me change my pen color real quick. SO4 is sulfate. Now, in this case, when you're dealing with the sulfur stuff, it changes up a little bit. You're actually going to not just change it to sulfic, because that would sound kind of weird. Okay, so we're going to go back in this case then and add back in the UR. And so that's going to become sulfuric acid. Okay, the stuff that's in batteries. Car batteries, not the kind of batteries that you put in your phone or anything like that. Okay, so ATE changes to IC. You'll note that we did not put a hydro in front of these. The hydro only goes if it's a binary, meaning there's only two things. If you see an oxygen, there's no hydro in it. Okay? Whoops. Let's get the slide there. Okay, so the other way then that polyatomics can end is in ITE. Okay, so like for instance, SO3 is sulfite. Okay? So if that's the case, we're going to change the ending to OUS. Now again, since this is sulfur and it looks kind of weird if we just make it sulfus, okay, we're going to add in the UR again, and then we're going to add our OUS. Okay? And so this becomes sulfurous acid. Okay? Not the same thing as sulfuric acid. Okay? A different sort of acid, a weaker acid, works in different ways. In this case, HClO, okay, so the polyatomic is ClO. If you remember the name of that from your polyatomics, that is hypochlorite. Okay? And so we're going to change the ending. We're going to erase the end of that. Take that ITE off the end. And we're going to change that to OUS. And add an acid. And that becomes hypochlorous acid. Okay? So relatively simple. Naming acids, naming covalent compounds, pretty easy. Here's the trick. This is what makes all of this hard. Is that when you're asked to name this stuff on the test or on the EOC, it doesn't tell you whether it's ionic or covalent or an acid or whatever. So you have to make that determination at the beginning. Okay, so anytime that you have a formula and you have to figure it out, what I like to do first is just run by and identify each thing as acid, molecular, as acid, molecular is covalent, or ionic. Okay, so here we go. This starts with an H, so I know that that's an acid. Okay, so how do we name acids? That's a polyatomic. I look that up on my chart if I need to, or hopefully at this point I have it memorized. I know that that is perchlorate, but I'm going to change the ending not to ATE. I'm going to change it to IC. Okay, so that becomes perchloric acid. All right, so easy enough. So I look up here, calcium is a metal. Anything with a metal is an ionic compound. So that becomes calcium. And then remember for ionic, we just name the anion. So when we change the ending to IDE, it's chlorine, but I change it to chloride, and that's it. Remember, I'm not really worried about that 2 because it's going to balance out anyway if I crisscrossed it. Okay? Like if I was given the name and had to find the formula, I'd crisscross it and I would get this. Okay, so it has to be CaCl2, so I don't have to worry about that. It's just calcium chloride. Okay, this other compound in the middle is molecular. How do I know that? Because both of those things are nonmetals, and it doesn't start with H. Okay, so I use the rules for molecular compounds that we talked about in this video. So I just name what it is. It's carbon. Okay, chlorine is chloride. Okay, and I've got 4 of them, so it's tetra. So carbon tetrachloride. Now, you're asking yourself, okay, how come I worried about the number in this one? I didn't worry about the number up here. Numbers matter for molecular compounds. Okay, the prefix tells us how many we have. For ionic compounds, I don't have to worry about the number because the charges balancing out takes care of the number. Okay, so I worry about the number for molecular. I don't really worry that much about the numbers for ionic. All right. So that's what makes it difficult. Today we're going to work some where they're all jumbled up and mixed up. And the first thing we're going to do is we're going to run through everything, identify